Well, this is the parallel resistance worksheet. Problems 1 through 5, you can see that there's 2 resistors. And problems 6 through 10, there's 3. So we'll use 2 different formulas to do this worksheet. Problems 1 through 5 will use R1, R2 over R1 plus R2. And 6 through 10 will use the 1 over each resistor, and I'll write that out. Just to look at the 2 formulas that we're using. The first one, R parallel equals R1, R2 over R1 plus R2. We don't have to put the times signature between these 2 resistors, R1, R2. And notice I like this little parallel symbol. In the NIDA software, they call it REQ, or R equivalent. And I prefer to just draw this little parallel. You can use either one. The second formula is what I call the 1 over R formula, and I like this one for any time there's more than 2 resistors. Here's an example using R1, R2, R3, so we have 3 resistors, and we put the dots after this formula because you can use this for as many resistors that you have that are in that parallel circuit. Alright, let's take a look at the first problem, and I'm going to show you how I want it written out for each of these numbers 1 through 5. Now let's say we have a problem with R1 equals 5K, R2 equals 8K. So the first step that you do is you write down the formula each and every time. So R parallel equals R1 times R2 divided by R1 plus R2. That's got to be there every time. And secondly, you put the values in for the equation. So we're going to have 5 kilo ohms and 8 kilo ohms divided by 5 kilo ohms plus 8 kilo ohms. Even though you could add that in your head, you don't do that yet at this stage right there. Now right here, the last step is just go ahead and calculate this. You don't need to put the product, the 40 kilo ohms squared, if you will, in the numerator over 13 kilo ohms. I don't need that next step. We want the formula, the values in the formula, and then the final answer with a box around it. So this is going to be R parallel equals, and let's calculate it. Bring the calculator in view here, and we've got 5 and an 8. So we got 5 kilo ohms. You should put in the exponent to the third, so 5 kilo ohms times 8 exponent to the third equals that. Now remember to use the parentheses. I don't think I hit divided by. I'm going to clear that and do it again. 5 kilo ohms times 8 kilo ohms equals, now divided by parentheses, 5 kilo ohms plus 8 kilo ohms, end of parentheses. When you hit the end of parentheses, it just calculates what was in the parentheses, so you need to hit equals to get the answer. Now notice that answer is 3076.92. We certainly don't want all that information. Generally, in this class, we've been keeping our answers to 3 significant numbers, and we have to convert the numbers back to the engineering notation. So going back to our lessons on engineering notation, this particular calculator even has an ENG button there, so it looks like you use the invert and then the ENG button, and it automatically converted it over. It says 3.0769 times 10 to the third. So 10 to the third is our kilo, and our answer is going to be 3.0, and we'll round that 7 up because of the 6 after it, 3.08 kilo ohms. 3.08 kilo ohms. And just as before, box around the answer. Now that's really all we need for this problem, but we're going to do something, we're going to look at it to see if it makes sense. We had a 5K and an 8K in parallel. Parallel resistance is always smaller than the smallest one. So right away we know that our answer has to be less than 5. And 3.08 kilo ohms is less than 5. So it makes sense, and that's the answer to our first problem. Alright, now we're going to take a look at a problem that has 3 resistors, and we want the total parallel resistance. So we're going to use the other formula, and this time we start off with R parallel equals 1 divided by 1 over R1 plus 1 over R2 plus 1 over R3. The more I say that, the more I got a chance of memorizing it. That's why I'm having you write it each time. Line up those equal signs. Now we put the values in. 1 over, and we just have a regular 6 ohms, not 6K for this example. 1 over 10 ohms plus 1 over 20 ohms. Like that. Okay, now we need to calculate this. And I want to show you a little trick that I do on the calculator to make this really easy. So the way I do it is I put each resistor in individually. So I'm going to put in 6, that's the first resistor, and I hit 1 over X. That's the right there, the 1 over 6. Plus, the next resistor is 10, so hit 1 over X. Your calculator may actually say X to the minus 1. That's the same thing. Now I'm hitting plus again, and I'm going to get the third resistor, the 20, and hit 1 over X for that. Now when I hit equals, I'm going to actually have solved the denominator only. So to get the answer, I have to flip that with the 1 over X key again. So one more time now with 1 over X, and there's my answer. I have 3.1, and I'll round it, 3.16. Before I write that down, I'm going to look at it. Does it make sense? I have, on this problem, a 6, a 10, and a 20, so I know it has to be smaller than the 6. 3.16 sounds good. 3.16 ohms, R parallel equals, and a box around it.